This is the video abstract of the paper Impedance Space Method, Time-Independent Parametric Ellipses for Robot-Compliant Control. Robotic compliant control is a way for safe and robust physical interaction. When testing the controller, such as the impedance controller, disturbances are applied to evaluate it. Such disturbances are commonly periodic, and plotting the interaction force versus the position error is a practice for experimental evaluation. However, the relationship between impedance model parameters and their graphical representations has often been unclear. In this work, we address this issue with three contributions: introducing a novel three-dimensional graphical representation of impedance, termed impedance space, which extends traditional two-dimensional plots. The impedance space combines the stiffness, the damping, and the phase plane representations. Presenting a three-dimensional elliptical curve in the impedance space, designed for a mass spring damper model under sinusoidal input. The mass spring damper model under periodic input has a planar elliptical trajectory. The trajectory plane normal vector is not time-dependent, demonstrating the suitability of this curve in fitting experimental data and characterizing impedance parameters. Inspecting the three-dimensional elliptic curve in the impedance space highlights how and why the apparent slopes on two-dimensional projections are not equal to the normal vector angles. The experimental results for each parameter set were as follows. Solid lines indicate the fitted three-dimensional ellipses. With these theoretical and practical results, we conclude the following. The proposed impedance space, a three-dimensional space, enhances the understanding of standard two-dimensional plots for mass spring damper impedance. While the inner force controller performance affected the rendered impedance, the experimental results emphasize the relevance of the parametric three-dimensional elliptic curve in the impedance space.